This movie covers IBESS topic 8.1, Human Population Dynamics, under the main IBESS topic 8, Human Systems and Resource Use. The significant ideas of this subtopic are: a variety of models and indicators are employed to quantify human population dynamics, right? To give numbers, not just the population size, but the dynamics of changing population numbers. Also, human population growth rates are impacted by a complex range of changing factors. Recall from topic 2 that a population is a group of organisms of the same species living in the same area at the same time and which are capable of interbreeding. For this topic, we are considering humans as the species living in the same area, namely the planet Earth. In this topic, we are also looking at demographics. Demographics is the study of the dynamics of population change. The population of the world on August 2nd, 2019 at 1 o'clock in the afternoon was 7,677,548,942. What is it when you are watching this video? Just Google World Population Clock to find out. Will the population ever reach simply too much? Recall from topic 2.1 that there are two types of population curves: the exponential or unrestricted population curve, or the J curve, and the logistic or restricted growth curve, or the S curve. Do you recall what environmental factors restrict or limit population growth? What are the limiting factors? What drives the carrying capacity of an environment for a particular species? Consider habitat, food, water, also predators and disease, and so on. Here is an image of human population growth over time. What shape of curve do you notice here? There are several demographic tools used for quantifying human population. They are crude birth rate, total fertility rate, crude death rate, doubling time, natural increase rate. You need to be comfortable with these words, their abbreviations, and how to use them in quantifying human population. So let's begin with providing some definitions. Crude birth rate is the number of births per 1,000 individuals. What do you notice about crude birth rates for lower economically developed countries and more economically developed countries? Why do you think there are differences in crude birth rates? Do not confuse crude birth rate with fertility rate. Crude birth rate is the number of births per 1,000 individuals, so that means old and young, male and female, in a population per year. While fertility rate is the number of births per 1,000 women of childbearing age. Childbearing age being somewhere between 12 and 51 years. So fertility rate is the number of births per 1,000 women ages 12 to 51 years. The total fertility rate is the average number of children each woman has over her entire lifetime. In this image, you can see that it is projected that on average, each individual woman will be having fewer children, hovering around 2 per woman. However, notice that in lower economically developed countries, women are still having an average of 3 to 6 children per woman. Different from total fertility rate is the general fertility rate, which is a ratio of total yearly registered live births, right, that's what goes in the numerator, to the over the female population of childbearing years. That's general fertility rate. Crude death rate is the number of deaths per 1,000 individuals in a population per year. How do average crude death rates compare to average crude birth rates? Do countries with high birth rates also have high death rates? To calculate crude birth rate, divide the number of births by the population size and multiply by 1,000. Because remember, crude birth rates are the number of births per 1,000 individuals. Likewise, to calculate crude death rate, divide the number of deaths by the population size and multiply by 1,000. Stop the movie and make sure you understand how these formulas work. It might seem obvious, but if the crude birth rate and the crude death rate are equal, that is when the population size will remain the same. Natural increase rate is the rate of human growth expressed as a percentage per year. In this case, migration, so emigration or immigration, is ignored. The natural increase rate is calculated by subtracting the crude death rate from the crude birth rate, and then taking that number and dividing it by 10. The rate is then expressed as a percentage. You can see by studying the formula and this graph that if you have an increase in births in 1 year and a decrease or steady rate of deaths, there will be a large number for the rate of increase. Stop the movie and study this graph until the numbers make sense to you as they relate to the formula. Make sure you learn the formula. You need to be able to do calculations with this formula. Doubling time is the time in years that it takes for a population size to double in size. From this table, you can see that doubling time is decreasing over years. So it takes fewer and fewer years for a population to double in size. A natural increase rate of 1% will make a population double in size in 70 years. Thus, doubling time can be formulated by taking 70 and dividing it by the natural increase rate. Memorize this. Make sure you understand this. Another calculation used in quantifying human population is population density. How closely packed are people living in one specific area? Population density is the number of people per unit area of land. So you take the population size and you divide it by the area of land. This typically will be number of people per square kilometer. You need to be able to calculate values of crude birth rate, crude death rate, total fertility rate, doubling time, and natural increase rate. You also need to be able to discuss and explain the relative values of these numbers. You will also learn how to analyze age-sex pyramids and diagrams. Let's begin by doing some sample calculations. Given the formulas I've already provided you, can you fill in this table? Stop the movie, copy down the table, and attempt to fill it in. Here are the calculations for the world. Notice how the units in the table have been adjusted to explain what the numbers mean. Again, stop the video and make sure you understand the formulas and how they are used and how to do these calculations. Now, complete the table. How did you do? Make sure that you can do these calculations. Having calculated the natural increase rate for each of these regions, now calculate the doubling time for each population. In other words, how many years will it take for the population to double in size? Remember the formula for doubling time. Here is how to perform the calculation for each region. According to these numbers, it will take the world about 64 years to go from 6 billion to 12 billion people. But it will take India only 37 years to go from 1 billion to 2 billion people. Why do you think there are such differences in doubling times for different areas? Complete this practice problem. Calculate the natural increase rate when the crude birth rate is 20 per thousand per year, and the crude death rate is 16 per thousand per year. Stop the movie and work out the calculation. Here are the workings for this practice problem. Note that this means that the population is increasing by 4.4% each year. Make sure that you understand these workings. Here is another practice problem. A population of 8,000 has 212 births and 172 deaths over a year. Calculate CBR, CDR, and NIR. And here are the workings for this practice problem. The answer of an increase of 0.5% in population size per year makes sense, right? Because there are more births than deaths. So you would expect an increasing population size. Taking the same practice problem where we just calculated NIR to be 0.5%, how long will it take for this population to double in size? I.e., what is the doubling time? Stop the movie and work out the calculations. Remember the formula for doubling time. Here are the workings. Make sure you understand how to get this answer, and that it means that it will take this population 140 years to double in size. In other words, 140 years to go from 8,000 to 16,000 people in its population. Global human population has followed a rapid growth curve, but there is uncertainty as to how it may be changing. Will it continue to grow rapidly, or will it taper off? What will happen in lower economically developed countries and more economically developed countries? We actually don't know for certain what the trend in the future looks like. Now, what do all these numbers mean when we quantify human population? We need to be able to explain the relative values of these figures. This image represents the natural increase in population per 1,000 people from 2010. Do you notice differences in natural increase rate for more economically developed countries versus less economically developed countries? Notice that virtually 100% of natural increase rate is located in lower economically developed countries, primarily in sub-Saharan Africa. Thus, these populations are contributing more to increased population growth. I already mentioned that total fertility rate has dropped dramatically among more economically developed countries, again hovering around 2 per woman, but it still exceeds 6 in some African countries, again contributing to population growth. This is an image of infant mortality rate, or IMR. You can see that IMR is also highest in LEDCs, again primarily in sub-Saharan Africa, which follows the patterns of NIR, TFR, CBR, and CDR. Perhaps high infant mortality rate contributes to high fertility rate. Families feel the need to have more children because the chances of the children surviving are so low. This is an image of life expectancy, how long people live in a given population. Life, where green, the greens, these people live longer. Life expectancy is higher in more economically developed countries as compared to lower economically developed countries. Thus, people in more economically developed countries are living longer, and people in lower economically developing countries feel the need to have more children, again hoping that there's a better chance that some of them will survive to adulthood. Here's an image of doubling time. Doubling time is also higher in more economically developed countries as compared to less economically developed countries. Thus, populations in lower economically developed countries are growing faster than more economically developed countries, contributing to increased population growth. According to this graph, the national increase rate was about 1.3% during the first decade of the 20th century, hitting an all-time high of 2.2% in 1963. The national increase rate has been slowly falling since the middle part of the 20th century and continues to decline. However, the number of people being added to the population is still larger because there is a larger base number to multiply the percentage with, right? So we still have increased population growth. Continuing to understand what quantification of human population means, you need to be able to analyze age and sex pyramid diagrams. as here's a general outline of one. Population numbers for age and gender of a location, region, or country are graphed to build what is referred to as age-sex pyramids or diagrams. Usually, on the left side of the pyramid, the male population is graphed, and on the right side of the pyramid, the female population is graphed, though sometimes you see these flipped. Along the horizontal axis of a population pyramid, the graph shows either the population percentage, either the population or percentage of the population of that age. The center of the pyramid is 0 and extends out to the left for the males typically and to the right for the females in increasing size or proportion of the population. Along the vertical or y-axis, age-sex pyramids display age increments of 5 years from birth at the bottom to old age at the top. You need to learn how to read and analyze age-sex pyramids and diagrams. By examining the shape of the diagram, you can learn a lot about the population of a location, region, or country. For example, the height of the diagram tells us what the life expectancy is. In this case, 85 years of age for both females and males. The steepness of the side tells us the death rate. Keep in mind that death happens at all age ranges. The size of the base tells us the birth rate. The dip here tells us the birth rate has dropped in the last 10 years. Look at these age-sex pyramids. Can you tell which one of the age-sex pyramids below shows a negative growth, a rapid growth, or a slow growth? Pause the video and study these diagrams to see what you think. How did you do? Relative to the rest of the population, there are a lot of very young children in this population, indicating a population in rapid growth. This population had rapid growth years ago when the people who are now 60 and older were born, but now there was a slow growth. And finally, this population has fewer children than adults, indicating that this population shows negative growth. Looking at this age-sex pyramid, can you answer the following questions? Who live longer, men or women? Where might there be a period of immigration or a baby boom just prior? Are more girls or boys born? Is there a period where there are higher death rates than normal? Is there a high or low birth rate? Pause the video and determine the answer to these questions. Stop the video and study this slide to make sure the annotations make sense to you. For example, the yellow bar is larger here as compared to the blue bar, indicating that there are more women in the 85+ year age category, suggesting that women live longer than men. I've included an insert here of infant mortality rate, illustrating that generally speaking, boys have a higher infant mortality rate than girls, which is referenced here in the annotation. But notice, these bulges here show either a period of immigration, so people moving into this region, or a baby boom years before that. Here we have a narrow base showing a small number of children being born, so a low birth weight. We have an indentation here indicating higher than normal death rates. Maybe there was a war or famine or disease. Or maybe there were a large number of people that moved out. And there is a broad shape at the top, shows that there's a higher proportion of people living longer. You need to be able to make connections with environmental value systems, with historical events and economical development. For example, can you think of 2 reasons to explain the decrease in population younger than 35 to 45 in China in 2007? Why is there this slight decrease here? Reasons to explain the decrease in population younger than 35 to 45 in China in 2007 could include China's one-child policy, The availability of contraception. If there's more contraception available and more people are using it, you're going to have fewer children. Urbanization and mechanization of agriculture. With people moving into the city or machines taking over farm work, there's less of a necessity to have a lot of children to work the farm. The opening up of China to Western influence and free market economy. And the high cost of raising children, so parents prefer to have one only. All could contribute to this decrease. Age-sex pyramids and demographic transition models can be useful in the prediction of human population growth. We are going to be discussing demographic transition models in the next few slides. The demographic transition model is a model which shows how a population transitions from a pre-industrial stage with high crude birth rates and crude death rates to an economically advanced stage with low or declining crude birth rates and low crude death rates. Here is the demographic transition model, which we will discuss in more detail in the next slide. Here are the stages of pre-industrial countries to more developed countries as outlined in the context of the demographic transition model. So stage 1, pre-industrial lower economically developed countries with high crude birth rate due to no birth control, high infant mortality rate, cultural factors encouraging large families, high death rate due to disease, famine, poor hygiene, and little medicine. Stage 2, early expanding lower economically developed countries. The crude birth rate is still high, so the population expands rapidly, and child mortality falls due to improved medicine. Crude death rate also drops as sanitation and food improve. Disease is reduced, so lifespan increases, right? You have more people living into older years. Stage 3, late expanding lower economically developing countries. They're now wealthier. The country becomes more developed. Crude birth rate falls due to access to contraception, improved health care, education, emancipation of women. The population begins to level off. Desire for material goods and low infant mortality rate means people have smaller families. Stage 4, low stationary medically, more economically developed countries, low birth rates and death rates, and these are industrialized countries, and you see stable population sizes. Stage 5, not depicted here, are declining more economically developed countries. The population may not be replaced as fertility rate is low. Problems increase of an aging workforce. Here is another demographic transition model. Stop the movie and study this slide as it outlines the different stages, right, of economic development with regard to population. It also provides examples of countries in each state of transition. This graph reinforces the idea that even though natural increase rate drops, population is still rising due to that initial base of people. Computer models can be generated to study and predict population growth. For example, I went to this website and generated this graph, which is a prediction of population size as far out as 2100. I recommend going to this site and creating some models for yourself to investigate population and what factors explain population growth. You need to be able to discuss the use of models in predicting the growth of human populations. Explain the nature and implications of exponential growth in human populations. Analyze the impact of national and international development policies can have on human population dynamics and growth. Discuss the cultural, historical, religious, social, political, and economical factors that influence human population dynamics. Let's start at the top. Use of the demographic transition model. The initial model was without stage 5. which has only become clear in recent years when countries such as Germany and Sweden have fallen into population decline. The fall in the death rate has not always been as steep as this suggests. Movement from the countryside to cities has created large urban slum areas which have poor or no sanitation and consequent high death rates of the young and infirm. Death from AIDS-related diseases may also affect death rate. The fall in crude birth rate assumes availability of contraception and that religious practices allow for this. It also assumes increasing education of and increased literacy rates for women. This is not always the case. Some countries have compressed the time scale of these changes. The Asian tiger economies of Malaysia, Singapore, and Hong Kong, for example, have leapt to industrialized status without going through this sequence in the same time period as others. And this DTM model is Eurocentric and assumes that all countries will become industrialized. This may not be the case in some failed states such as Syria, Afghanistan, or Yemen, for example. The issues of using computer models. Validity depends on quality of data. Possibly the data is more accurate in more developed regions. The model basis could be flawed. Real world could change, so model has to keep up with developments. However, computer models can be useful to help predict demand in each country for schooling, medical services, the workforce, etc. It could also help governments plan ahead. Let's explain the nature and implications of exponential growth in human population. Quite simply, as the human population grows, increased stress is placed on all of Earth's systems. Can you try to understand how could the atmosphere be affected or stressed by increased human population? Or the biosphere, geosphere, and hydrosphere? How are all of these stressed upon with increased population? The more people there are, the more resources are required. More people need more food and water. Also, more people eventually all want an increased standard of living, which requires more material goods and results in higher energy consumption. The more people there are, the greater the impact they have. I just talked about increased use of resources, but also, what about increased waste and pollution? Imagine the impact there. Resource use varies in time and space. For example, MEDCs and LEDCs demonstrate varying resource use. Urban and rural environments demonstrate varying resource use. Young people have different resource demands than elderly. Just think about your own energy consumption compared to your grandparents. Amazonian Indians, for example, also have much different resource needs than Parisians. Also, if you consider waste and pollution generated by certain population as compared to others, that is also different. What is the consequence of using up all of our resources? Resource failure. Some examples of resource failure include the Great Chinese Famine of 1959 to 1961, in which at least 45 million people died. Groundwater loss in India in 2015, visible from space. And very recently, this year, 2019, the city of Chennai in India reports that there are 5 million people running out of water. Obviously, food is an issue when considering the sustenance of the world population. There are two main theories relating to the population growth and food supply, the Malthusian and the Boserup. The Malthusian theory, proposed by Thomas Malthus, assumes the human population increases geometrically, 248-1632. And that food supply grows arithmetically, 2, 4, 6, 8, 10, 12, etc. The population can never increase beyond the supplies necessary to support it. When the population reaches the critical point, there will be war, famine, and disease. There will be crisis. Limitations of this theory. It's based on a closed community. In reality, communities are not closed because of the constant in and out of migration. It is also too simplistic. Food supply is not simply a matter of land's capacity to provide food. We know that there is an uneven distribution of available food. It's the poor who suffer hunger. Also, the high price of food limits its availability. And evidence suggests that food surpluses do exist. Malthus did not expect the impact of technology and globalization on food generation in our day. The Esther-Bostrup theory states population growth would increase technologists to increase food production, right? A technocentric view. And it's not necessary to limit the population, therefore, because we will find ways to feed the people. Limitations of this theory is that it is also based on a closed community. Overpopulation can lead to unsuitable farming practices, and population pressures do not always lead to technological innovation and development that supports the population, right? This kind of development is limited to the more economically developed countries. Higher intensity of agriculture might lead to greater food production. However, we must account for pollution, degradation of soil, erosion, desertification, toxification. Otherwise, population crashes might occur. Influences on human population dynamics include cultural, historical, religious, social, and political and economic factors. Factors that influence the decision to have large families. High infant mortality rate. It is an insurance to have more than you may need so that some of them will reach adulthood. Security in old age. The tradition in family is that children will take care of their parents. The more children, the more secure the parents, and the less the burden on each child. Children are an economic asset. In agricultural societies, children's work on the land as soon as they are able. More children mean more help, but more children also need feeding. In more economically developed countries, children are dependent on their parents for their education and take longer to contribute to society. Status of women. The traditional position of women is that they are subordinate to men. They do most of the agricultural work, do not have the opportunity of education or career, and their social status depends on the number of children they produce, particularly boys. Unavailability of contraceptives. In more economically developed countries, this is the prime way of reducing fertility. In lower economically developing countries, women are too poor to pay for them or to get access to them. Influences that can reduce family size. Provide education in the form of basic literacy to children and adults. Improve health by preventing the spread of diseases through simple measures of hygiene, improving nutrition, and providing medicine and vaccinations. Also, provide contraceptives and family counseling. Enhance income by small-scale projects focusing on the family level. Small loans can provide a family the means to invest in the tools needed to generate income, like seed and fertilizer for farming, bread pans to bake bread, yarn for weaving. Improve management, resource management. Local people may grow trees, seedlings, for transplantation and reforestation efforts, prevent erosion through soil conservation work. Large-scale projects such as building dams or roads do not help lower economically developing countries because they cost too much money, putting the country into debt. National and international development policies may also have an impact on human population dynamics. Policies that may reduce population growth. Parents in subsistence communities may be dependent on their children for support in their latter years, and this may create an incentive to have many children. So, if government introduces pension schemes, the CBR comes down. If you pay more tax to have more children or even lost your job, you may decide to have a smaller family. Policies that stimulate economic growth may reduce birth rates as a result of increased access to education about methods of birth control. Urbanization may also be a factor in reducing crude birth rate, as fewer people can live in the smaller urban accommodation. Policies directed toward education of women and enabling women to have greater personal and economic independence may be the most effective in reducing fertility and therefore population pressures. Policies that may increase population growth rates, agricultural development, improved public health and sanitation may lower death rates and stimulate rapid population growth without significantly affecting fertility. Lowering income tax or giving incentives in free education and healthcare may increase birth rates, like in Australia, the baby bonus. Encouraging immigration, particularly of workers. For example, Russia allows migrants who do not have qualifications to fill the gap in manual labor. Here is a summary of the significant ideas, knowledge, and understanding application skills that you need to gain from this subtopic. Stop the slide and read through everything. If you need to review, go back into the movie and listen again. This ends the movie for IBESS Topic 8.1, Human Population Dynamics, under the main Topic 8 of Human Systems and Resource Use. The slides were created by me, Dr. Nina Markham. Images are courtesy of Creative Commons unless otherwise indicated, with a citation under the image. If all images on a slide are from the same source, the source is simply cited at the bottom of the slide. Another resource for you is your IBESS textbook, whether in hardback form or online, such as Cognity. Thanks for listening.